Hey guys, welcome back to another lesson for Math 7, lesson 113. We're going to be talking about volume, and it's going to be volume of pyramids, cones, and spheres. All right, so I'm going to actually bunch together the pyramids and cones, and then we're going to do spheres by itself. So let's actually go first over volume of pyramids and cones, and then we'll do spheres. All right, so let's get into the lesson. All right, so on the board I actually drew two types of pyramids. I'm not going to draw the third type that you have in your book because it's a pentagonal pyramid, but that's kind of weird. We don't really use that one as much. We use mostly this one or this one. This one is a square pyramid, all right, and this one is a triangular pyramid. So they're both are pyramids. They have pointy end, right? And they have a base that is a polygon. Polygon has edges, straight edges, and it has vertices, right? So straight edges and vertices, and that's what happens. So you could have more polygonal pyramids. As I said, you can have a pentagonal, hexagonal, heptagonal, octagonal, nonagonal, and so forth. You know, I'm not going to name all the types of polygons there are. This is not what the lesson is about. It's about these types of shapes. And so what you have to understand is that just as any volume, we would start with saying that volume is the area of the base times the height, right? So we are actually going to stick to this basic formula. It's going to change a little bit because if this was a, and let me actually use like a cube to illustrate my point with a pyramid. And so, how do you draw a cube? I think I'm making this more complicated than it needs to be. Let me just redraw this. Let's make a square, somewhat like a square. All right. So we have a cube. Inside the cube, we have a pyramid. All right, so we have a pyramid inside the cube. Now, we understand something, that for the cube, the area would be the area of the base, the volume, sorry. The volume would be the area of the base times the height, which the area of the base in here for both the pyramid and the cube is a square. All right, so it's pretty easy. So in here, if we say that this side is 5 and this side's 5, then obviously we know that the area of the base is 25, and let's say it's in inches. So it'll be 25 inches squared. Yes? Easy. Now, we have the height here that is 5 inches. And that's what we have, all right? So we have 5 inches by 5 inches by 5 inches. And that would actually give us the volume, then 5 inches here. Obviously, 125 inches cubed would be the volume for the cube. The volume of the cube is 125 inches cubed. However, we understand something. The pyramid does not fill the whole thing. It actually leaves some space in there, right? If this was a box and we put a pyramid in there that had the exact same base, so it fits perfectly in there, we'd still have a lot of space. Look at that. We have the space all the way on top, and we have the space like that goes around it, and space over here too, and space over here. So it doesn't fill the whole box. So we understand that the volume of the pyramid cannot be the area of the base times height. It has to be a fraction of it. It has to be part of it. Is it going to be half? No, half is still too much because you're also forgetting that in the back you can still fit a lot more. It's actually about closer to 1/3. And so what happens is that the volume of the pyramid is going to be 1/3 the area of the base times the height. And that's what we're going to use for the formula for the area of a pyramid. I just want to make sure that you can see what I wrote. Yes, that's fine. And so that's what's going to happen here. And let's actually talk then about, and I told you I was going to talk about pyramid and cones together. Let's talk about a cone. All right. And a cone is the same thing as a pyramid, except it has a round, circular base. All right. It's a circular base, and it's the same problem. We are not going to fill the whole cylinder. And what is the area for the volume for a cylinder anyway? The volume of a cylinder, it's going to be the area of the base times height. Well, the volume of the cone is going to be 1/3 of the area of the base times height. It's the same principle as the one I just showed you with the pyramid. It just doesn't fill up the whole thing. The only thing that matters here is the area of the base. The area of the base here is a square. The base is going to be found differently, the area of the base, than the area of the base here for the cylinder, because the cylinder is a circle, and therefore it doesn't have the same formula. And you have to understand, this one is a polygon, this one is not. A circle is not a polygon, it's a circle. All right, so that's what we wanted you to understand. The volume of the cone and the volume of the pyramid would look very, very similar, but the only thing that changes mostly is how you find the area of the base of both the pyramid and the cone. Now that we talked about this, let's actually get into examples. And now I don't have to stop to talk about how you find the area of the cone. All right, so in example one, and I promise you, I didn't even know that in example one, we're going to use a cube. And a pyramid. Okay, so we have a cube and a pyramid, and each side is 6 centimeters. So they ask us, find the volume of the cube and find the volume of the pyramid. Well, if you looked at what I just showed you before we went into the examples, we know that the volume of the cube is going to be the area of the base times the height. The area of the base is going to be 6 times 6, which is 36, times 6, right? So it's 6 cubed. And that would be 6 times 6 is 36, and a 3 goes up. 3 times 6 is 18, plus 3 is 21, 216 centimeters cubed. All right, so we know that the volume of the cube is 216 centimeters cubed. I'm just checking that I got my math right. All right, I did. And now we're going to do the volume of the pyramid. Now, thinking logically, we understand that 216 is it's not a huge number, but it's a bigger number than what the volume of the pyramid has to be, because the volume of the pyramid is going to be just 1/3 of the area of the base times height. And so we're going to have 1/3 times 36 times 6. And that would be it. Now, I'm going to actually cancel this out before I do any math. So 36 and 3 can both be divided by 3. And so it'd be 1 and 12. 12 times 6 is going to be 72. This is going to be 72 centimeters cubed. And that is how you do example number 1. All right, and now we have to find the volume of a cone. And the volume of the cone is going to be 1/3 of the area of the base times height. The area of the base, though, how do you find the area of a circle? You have to know this by now. The area of a circle is going to be pi radius squared times the height. So the volume would be pi is 3.14. Radius would be 10, because if the diameter is 20, the radius is 10. And the height is 30, because this is 30. I know that there's a little bit of glare. There's a little bit of glare right here in the 30, but what are you going to do about it? All right. And so now we have 100 because 10 squared is 100 times 3.14 times 30. This is going to be easy because 100 times 3.14 is going to be 314 times 30. I'm actually going to use the dot notation for multiplication. And so it's going to be 0 times 4. Oh, we're just going to multiply times 3 and then add a 0 at the end. 3 times 4 is going to be 12. And a 1 goes up. 1 times 3 is 3 plus 1 is going to be 4. And 3 times 3 is going to be 9. And it's going to be in what? In inches? Centimeters as well. Cubed. 9,420 centimeters cubed. And that's how you find the volume of a cone. It's actually pretty easy. So yeah, let's move on to spheres now. Okay, so go back to our example at first. And I know I'm not in the camera, but I was just making sure that you could see what I put on the board. This cylinder, right? So it's a cylinder that I put a little ball in, all right? So understand that this is like a little ball. It's a cylinder in there. And so what happens is that we have the cylinder, we have the little ball, and then what we need to do is we need to find the volume. So we know how to find the volume of a cylinder because we already did it. We did it before for a for the cone. We know that it's the area of the base times height. The area of the base obviously is a circle, and the height is going to be that. However, for the sphere, it's going to be a little bit different because the height of the sphere is also going to be the circumference of the circle, of the sphere. And so what you have to understand is that right here, the base obviously has a diameter, but I'm going to call it radius, okay? So it's going to be how many radius in one diameter? 2 radius. So it has 2 radius right there, and the height is also going to be 2 radius. It makes sense. Why? Because if we have a perfect sphere that fits in there, it's going to be this one and this one that it's there. So it's just that way it's supposed to be. Now, how is this going to work? Well, the first thing that I have to do is find the area of this cylinder, and I'm going to leave pi as pi. So I'm going to leave pi as pi. I'm not going to use 3.14. I'm not going to use 22 over 7. I'm going to say pi is pi. So I'm going to leave pi as it is. So the area of the base, again, we just did a problem. Volume of the cylinder is going to be pi radius squared. It's easy, and the reason I decided to go with 2 radius and not 1 diameter is because what is 1/2 of 2 radius? 1/2 of 2 radius is just 1 radius. So pi radius squared times 2 radius. That's what it's going to be. Now, what is radius squared? Okay, so this is very important for us to understand. What's going to happen is that the cylinder then is going to have a volume of 2 times. What is radius times radius squared times radius? Well, radius squared is radius times radius. And if I multiply times radius again, I'm going to radius cubed. So it's going to be cubed. 2 pi radius cubed. And that's going to be my volume for the cylinder. 2 times pi times radius cubed, I think. Let me just check that my math is right. Yes, it is correct. So that's it. That is where we're going to get our formula from. And so now that we understand this, again, just like the cone and the cylinder, not cone and pyramid, we have all this space around the sphere that is not filled up, that we can actually fill up with something else. And so what can we say about it? Is it going to be 1/2? No, it's going to be more than 1/2. Is it going to be 3/4? 3/4 is too much. 75%, it doesn't fill 75% of the cylinder. It actually fills 2/3. So the volume of the sphere will be 2/3 big B times H. Right? 2/3 of big B times H. However, we already found out big B times H over here. So let's just put that there. So the volume of the sphere is going to be 2/3 times 2 pi radius cubed. Yes? Pretty easy. Now, what is 2/3 times 2? 2/3 times 2, I'm going to write it probably over here. 2 times 2 is going to be 4/3 pi radius cubed. That is the formula for the volume of a sphere. And that's how we get it from this little explanation right here. So I hope that you understand it. Now let's move on to example number 3. All right, so in example 3, they tell us, well, we have a ball with a diameter of 20 centimeters. What is the volume of the ball in itself? So to be able to find the volume of the ball, what we're going to do is find our formula, or know our formula. The formula is the volume of a sphere is 4/3, not 3/4, 4/3. 4/3 pi radius cubed. Okay, so what is our radius? Our radius, because the diameter is 20, is going to be 10. So the volume of this particular sphere is going to be 4/3 of 3.14, because we are supposed to use 3.14 for pi, times 10 cubed. 10 cubed is going to be 1,000. 1,000 times 3.14 is going to be 3,140. 3 plus 1 is 4, plus 4 is 4, plus 0. It cannot be evenly divided into 3,140. It cannot, right? No, it cannot. We're going to have a fraction here. So what I'm going to do is I'm going to divide 3,140 divided by 3 and then multiply that by 4. So I'm going to do 3,140 divided by 3. It's going to be 1, 0, 4, 6, and 2/3. So I got 1,046 and 2/3, and then I have to multiply that whole thing by 4. But because the 2/3 is right here, I don't have to multiply 2/3 by 4. I only have to multiply this by 4. And so it's going to be 1,046 times 4. 6 times 4 is I do have to do the 3/4. My bad, 2/3. But I'm going to do first the whole numbers, and then I'm going to multiply 2/3 times 4 over 1, which is 8/3, which is the same thing as 8/3 is 2 and 2/3. You see, I'm tired. That's why my math is not flowing. 6 times 4 is 24, and a 2 goes up. 4 times 4 is 16, plus 2 is 18, and a 1 goes up. 4 times 1 is 4. So I get 4,184. Plus 2 and 2/3. I get 4,186 and 2/3 centimeters cubed. Yeah, 4,186 and 2/3 centimeters cubed. Your book rounds it up to 4,200 centimeters cubed, but it's the same thing. And that would be it for this lesson, lesson 113. 7 more lessons to go. Yes, 7 more lessons. So yes, we are moving along, and thank you for watching. I will see you in the next one.